right, so if we take a look at our first sheet, come on now, it's not letting me zoom in very much. Okay, so here we're going to talk about congruent triangles. If you want to know what topic or part this covers, this is 4.1, okay, ish. So congruent triangles have the same shape and size. This means all corresponding parts, which are all the angles and all the sides, are congruent. And because these parts are congruent, we have to name triangles a very specific way so that the corresponding parts line up. So it says when triangles are congruent, we can write a congruency statement. In this case, if we talk about A, B, C, you could see that A would be congruent with D, B would be congruent with E, F would be congruent with, or C would be congruent with F. AB is congruent with ED, BC is congruent with FE, and AC is congruent with FD. So when we name this, we have to be very specific as to what goes with what. We have to make sure angle A lines up with angle D. So we would answer A and D first for each triangle. B lines up with E, and then C lines up with F. But you should also look here that this side, AB, should line up with this side, ED. So there's AB, there's ED, okay? And then BC, whoops, different color. BC should line up with FE. So here's EF, which works fine, and BC. The last part with AC and FD, you're basically looking at the two end points or vertices, okay? Questions on naming. It has to be, and now it doesn't matter if we switch this up. We could have named this like CAB and then FDE. But you have to make sure the parts are together, okay? Questions on that? That's very important. Okay. All right, so this next part, CPCTC. Now, we're going to use this eventually in our proofwriting, but we're just going to kind of talk about what it is. It means corresponding parts of congruent triangles are congruent. If we know two triangles are congruent, then we know that each pair of corresponding parts are also congruent. So when we do our proofwriting, something you're probably going to want to write down is that you must prove triangles congruent first. Okay? Then you can apply CPCTC. That I'm doing that early. We're not proofwriting today. You won't proofwrite with CPCTC for a little bit. You need to get rid of that food, please. It's not allowed in the classroom. If you need to eat, please step outside. Too many food allergies. Sorry. CPCTC will probably be one of the last things we do, but it's important. I'm going to keep stressing it as we go along, though, okay? Because that's the one thing students seem to forget. Questions on this? Is anybody still writing this down? Yes. Oh, then apply CPCTC. So you got to prove triangles congruent first, then apply. CPCTC cannot work unless you have congruent triangles, bottom line. Okay. If you try to apply CPCTC before you have congruent triangles, something goes very wrong very quickly. Because it literally says congruent parts of congruent triangles. So that's kind of a big deal. Oh my gosh. All right. So let's take a look at this first part. This says list all congruent angles and sides given the congruency statement. So we are given triangle JKL is congruent to triangle PQR, and we are just going to list the congruent parts. So in this case, the angles are pretty easy. Angle J is going to be congruent. Sorry, it looks like a T. Is going to be congruent to angle P. Angle K is going to be congruent with angle Q. Angle L is going to be congruent with angle R. Now the sides, we need to look at each individual piece, right? So JK is going to be congruent with PQ. KL is going to be congruent with QR. And in this case, JL, looking at the two end vertices, is going to be congruent with PR. I'd like you guys to try two. In fact, try three also, now that since you're at it. Try 2 and 3. Gavin, where's your phone?
It's like the second day of school.
I know, right? So no plane. Abdul, oh, where's your phone? What is up, guys? I thought Kira was the only one having a bad day. I said, Carol, I thought you were the only one having a bad day. Which is all other people forgot their phones. How could they? Okay. So no Blaine. All right, who's still working on 2 and 3? Okay, I'll give you another minute. Shh, guys, let's keep it down. I know it's Friday. I know we're all anxious for the weekend, me in particular. But... What'd you say? My son played that with my nieces last night. I called them. I haven't seen my nieces in like forever, and I called my sister from another mister, you know, and she's like, "How's it going?" Blah blah blah. And then like, my niece October told, "Hi, you sound familiar." I'm like, "Oh, ouch." I go, "It's Aunt Erin." "Oh, hi." I go, "I'm sorry, I didn't remember your name. Where's Gavin?" That's my son. I go, "So you remember Gavin, but you don't remember me?" She goes, "Yeah." Huh? They are. And they're cute. Leah, I told my friend that Leah is a lot like me growing up. Godspeed. She's sweet. I love her. I love the fact she says what's on her mind, you know, like I love her. If I had a daughter, I would hope she'd be just like Leah. Okay, let's take a peek at these. So here is 2 and here is 3. Check those out. Guys, check them out. Now, the naming of the triangles, if you guys look right here, they were very specific with the naming, okay? That means if MPK, we're talking about MP to K, this has to line up as CYA. There's no ifs, ands, or buts about that, okay? Any questions on 2 or 3? Yeah.
So, like on B, it would be wrong if I put the
That would be okay. I'm talking about when you name the triangles, all the parts have to line up. But when you're naming segments, just like before, same rules. Good question. Any other questions? Okay. The reason why is because these are also specific angles. So you can't like mix up the angles. Alrighty, we're gonna skip 4. Let's go to 5. Now this one, they're just saying, hey, what are these values? Seating chart next week, guys. We tried it. Yeah. It's way too talkative. I was literally just sitting here quiet for a few minutes. And so, seating chart next week. All right. So, number 4, we have BN. Okay. And we're saying that's congruent with what? Well, we might have some angle measures. Then again, we might not. It really does kind of depend. Okay. But one thing we can do is that WS, that are saying STW is congruent with BFN. So these line up. So if we're looking at BN, that means SW is the corresponding side. So which means that should be 9 centimeters. Next one is TW. So I'm looking at TW with FN. So here's TW, here's FN. So that should be 14 centimeters. And now looking at BF, so BF, ST, so ST is 17, that means BF is also 17 centimeters. Now the measure of angle W is lining up with the measure of angle N. Angle N is 82 degrees, so this is also 82 degrees. Angle B lines up with angle S, so that ends up being 67 degrees. And angle F lines up with angle T, but we don't have a measure for angle T. So what do we do here? Good. Very good. So this is 180 minus 67 minus 82, which should give you 31 degrees. Questions on that? We're going to skip 5. We're going to move on to 6, though. All right, part 6. So given UVW is congruent to TSR, find the values of X, Y, and Z. All right, so in this case, if we're looking at UV, that's congruent with TS, which is 53. So this will be 12X minus 7 equals 53. Add the 7 to each side. That leaves you with 12X equals 60. And then you have, in this case, when you divide by 12X equals 5. Take a minute and solve for Y and Z, please. So we already covered this part and this part. Remember, do not eyeball this. You want to use the congruency statement given to you.
That's one. 18. I don't know.
Show hands. Who's still working on these 2? All right, another minute. All right, what does y equal here? Who could tell me? Izzy. 18. And what does z equal? 12. Very good. Does anybody need to see the work for these two?
It does.
Well, you guys need to keep in mind that it's not always going to be this easy, right? So maybe they'll give you a quadratic. So there you go. But this just gives you the setup and the idea more than anything. Okay. You're not associating with them? Is that what you're telling me, Izzy? All right, let's get through 8. Now, in this case, they're going to give it to you in words, and this can happen from time to time. So what I would recommend is drawing the shapes. So it says if triangle DEF is congruent to triangle JKL. So I'm just going to draw DEF and then JKL. Pictures always help. Now remember, it's not telling us it's obtuse. They're not really giving us any information. We are just doing this as kind of like, think of it as like a blueprint. All right. Nothing's really built yet. It's just to give us an idea where things go. So if we look at DE, that's 18. I'm just going to fill in the spots. EF is 23. DF in this case is 9x minus 23. Then we have JL, which is 7x minus 11. JK, which is 3y minus 21. And it looks like that's about it. So they want us to solve for X and Y. So what I want you guys to do is I want you guys to set these up on your own and see how this works out, okay? It's not just me. It's hot in here, yes?
Yeah, it is. It was really
Because my husband's looking at me, he goes, why are you so hot? Because the school is boiling. He goes, oh, you're just... There's like a whole process with that boiler. That's why they do it when they can. Yeah. Our boiler broke. Bring a scarf. All right, show of hands. Who's got X and Y? Awesome. What'd you get?
X is 6 and Y is 13.
Very good. X is 6. Y is 13.
Why is 16? Not
No, it's 13. Yup.
Oh, I can't do basic division. That's why.
Okay, we're going to skip 9, but if you want to, anything that we skipped, if you want to do those as extra practice, you're more than welcome to. We do need to get to the last sheets. All right, here, this is not extra credit. Huh? Actually, I hate to break it to you, it's not surprising. No, you don't. Like there's a lot. Uh-oh. Wrong one. Hold on. Let me get, I thought it, oh no, wait, I didn't put it in here, did I? I put it in here. All right, we do need to complete example 2 from the book because you're going to see something similar to that on your test. All right, so here we go. So it says verify congruence. Use rigid motions to verify whether triangle XYZ is congruent to triangle ABC. So rigid motion, again, what does that mean? Who remembers? Go ahead. Yeah, we did that all of topic 3. Anytime you reflected something, anytime you rotated something, anytime you translated something, or the composition of it all, you performed a rigid motion. Now what they're doing is they want you to find what the composition like function is, okay? So if you take a look at this, now there's going to be more than one way to do these. But if we take a look at this first one, it says if a rigid motion maps triangle XYZ to ABC. So here's XYZ, here's ABC. So what they're telling you is that through this congruency is that X and angle Y are supposed to be congruent to each other and map onto each other, okay? The thing that they're saying is you need to first rotate 180 about point Z, okay? So if we're doing 180 about point Z, that's 2, 2. That's when you apply, okay, here's this, okay? Going across, find those new points, okay? And see where it lands. Now, do you always have to rotate about a point? No, there's more than one way to do this, okay? I am definitely the type that likes to rotate about the origin and then go from there, okay? After that, you would translate the image 3 units to the right, and then you have what you need. And this is our function. Rotation, that should be little r, not big R. 180, comma Z, and then translation 3, 0. So here's what you need to focus on. Think of other solutions. Can you identify another composition of rigid motions that maps one triangle to the other? That is what they're trying to get at. So what I want you to do in example 2 is find a rigid motion. Okay, I want you guys to find one. We'll try it out. And then I'll give you like another 2 just to give you examples. Okay. So see what you can do. Map GHJ onto KLM.
I don't know. I'll figure that out. I'll tell her. I'll tell her not to do that.
She kept bringing it up. And then he was like, Brandon was like, yeah, at least you're going to
What do you think you're going to come up with your What was the point of these? It's about like manipulation. We're gonna stop it.
As literally was
You
looking
could have typed it out and then the back page was the answer for that.
like I want
Nothing.
Is the guy fishing?
No, because there's no results.
I wasn't as I didn't know you just
When there's no chance at all, and people just want to do
Gentlemen, how we doing? We got a composition? Like I said, it is on your topic 4 test. I'm not gonna lie. I'm not lying here.
How much would you translate?
Just one? About what?
Oh wait, no, he's actually right. Wait, he's right. He's right. Oh no. Rotation around the word. Make sure when you're writing out, you write it.
That's what I'm saying. Give it a shot. See what do you see?
What's the thing for reflection over?
You can do a couple reflections here. I did a couple reflections for one of them. Yeah. I'm not saying I'm against the idea of you doing a reflection. I'm just saying I don't think you're going to get it right if you do it just about X, negative X.
But I really had
I'm still yet to know if this is right. So don't quote me on this. That's why they. Dude, I love you.
Oh,
It's negative. Yeah, it's -2. It counts by twos.
Okay, so now.
It counts by two. No,
No,
it's not. Look, this is right on the two.
How we doing? Almost. This is going to require a little bit of visualization. Then there's
What's the thing for reflection? Is it just an R or is R for rotation when you're writing?
capital letter R.
Oh, okay, I got it.
Little r is for reflection or rotations. Okay. So here's one that I got, okay? This is just one of them. You can do a reflection about x equals 1 after you do a reflection about y equals -2. I wish this thing would stop jumping all over the place. So does this work? I don't know. Let's see. So here's y equals -2. If I plotted this, this would be g prime. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's h prime. And then here is y prime. 1, 2, 3. It should be 5 also. 1, 2, 3, 4, 5. Yeah. So there's my first reflection, right? Then I can reflect it again. No, there's a ton of ways. I'm just giving you what I saw. If I reflected this again, it lands on here. Now, another way, if you wanted to get fancy, you could have done a translation to -12 and then rotated it 180 degrees about the point 2, -8. That's another one. You can rotate this about the origin 180 degrees and then translate it down. Do you guys see how, like, there is a bunch of ways this can be done, but you guys need to use your visualization, okay? What are we looking at? My pen's dragging today on the computers. -12 to -8. Huh? This point? All I did was I kind of like, okay, well, what's going to get me in the general vicinity? And then I just found the center of it. Like, honestly, that's all I did. But you don't, like I said, you don't have to. If you rotated this about the origin and then translated it, you'd get the same thing. Does that make sense? Like I said, I went fancy. I don't have to, though. You know? All right, questions on these. Guys, go all the way to the back of the packet because I don't want you to miss these. Last page possible. You have 2 homework problems for this. Okay? So take your time and don't forget the back page. That's all I wanted to bring to your attention. Are there any questions? You have all the other pages, but I didn't want you to forget about these on the back. I'm sorry? Yes, you're turning this one in, yes.
No,
all of it. All 3. Yeah, all 3. I don't have, there's nothing on Samus for this. That's the problem. There's no Delta Math either. You guys keep asking me for things that, like, I don't have. Like, that's the thing. This is the best I could do. Huh? They are. They're getting better, but they're just not there yet. Delta Math especially, it's gotten a lot better over the last 3 years, but it's still not there. Any other questions? Okie dokie. Have at it. Those of you watching at home, have a great day.